Anthony.
Ben.
Yes. Okay, I think we're gonna take this. This is perfect. It doesn't get better. But anyways, now that we're both here, it's time for another episode. And I think we kind of spoiled last week what we're gonna do
hmm
today because last week we were talking about that S3 storage,
Sure.
and we also briefly mentioned how we could use offloaded data in an S3 storage and kind of
Mhm.
combine it with one of the topics that we've been talking about a lot in the past, which is embeddings.
Embeddings,
So
yes. Rather than the artificially generated sales data.
I mean, I sometimes feel like I can't really win with you, but that's okay because
Likewise.
you broke
Likewise,
my
Ben.
demo back then for the pre-con. So
It was 2.5 years ago, Ben.
yeah, a factually correct statement that has nothing to do with what I just said. But good memory. I remember too.
Yes. We could
Uh,
celebrate the anniversary this November at Pass Summit 2025.
however, I also feel like this got us closer together because I was a very trustful person before, and since then I have your trust issues. So I kind of feel like
Yes.
it was good for us.
Yes. Yes.
Shall we, before this rabbit hole catches up on
Yes.
us, shall we
I
dive
feel
into the
like
demo?
I feel like our drop off rate is accelerating. Yes, let's get started. So I want to show today is how I want to use external tables to store vector embeddings. What I really want to highlight here is how we can manage kind of the size of these things that are going to be coming into our database. When we look at embeddings, they're going to take up a lot of storage, and we're going to think about how I can place that data in the right places in my infrastructure, whether I need it to be on that hot sub-millisecond block, or maybe take some older, let's just say less high value data and put it on external storage. So let's walk through that. I'm going to use a copy of the Stack Overflow database where I've gone through and I've generated embeddings for all of the posts titles. And so let's get started with this
Let me add
process
one
here.
point to that because all you've said is entirely right, but there may also just be situations where you want to add embeddings to your database, but you don't really
Mhm.
own the database because you're using a third-party vendor software that is bringing its own
Ooh, that's an
database.
interesting scenario. Yeah.
So I still want to use all that Gen AI. I still want to chat to my product catalog, but that sits in a Dynamics database, and I can't just add columns and all that. So,
hmm
well, I 100% agree that there
Wait,
may be storage and architectural decisions that go into it. There may also just be situations be like, I just can't do that.
are you telling me people have never adjusted a third-party vendor's database, like added indexes or table? No one's ever done that before?
People do that,
Yeah.
but usually they take a log of what they're doing because at some point they run into a support case and then they roll all these
Mhm.
changes back before actually filing the ticket because,
Yeah, yeah. Third-party support. Get it. Cool. All right, let's get cracking, Ben. We're
yes.
going to start off by creating a master key inside of our database and a database scope credential, which is going to authenticate me to my external storage. So it's going to
Uh-huh.
run this code here together to do just that. I'm not going to obscure that access key, but I'm going to scroll really, really fast. We're going to go ahead and define where that external storage is in my infrastructure so that we can see the network location of an S3 compatible object storage product that I'm using on prem, which is a pure storage flash array, but there are other solutions around that as well. And so my bucket there is AEN SQL Dataver, which is the bucket that I'm going to interact with to store the data that we're going to generate. I'm going to be using the Parquet file format because what I'm going to do is we pick up that data out of SQL Server, we'll compress it and write it into files inside
Because last
of
week I
Parquet.
told you always use Parquet. You're a good listener,
Yes,
Anthony.
not butter. Let's go and run that code here. And we'll do that. And we'll have that kind of all the infrastructure elements set up to interact with that external storage now. Now, as we learned last week in Ben's demo, we have the ability to just turn on external Polybase exports. Now I can do file and object level interactions with SQL Server without having to install any additional stuff. I just turn it on, and now I have access to this integration. And so for this demo, before I go and scoop up millions of rows of data and stick it into that external object storage, I'm just going to do a quick smoke test to just use the CTAS function or the create external table as select, just to scoop up 10 rows, throw it into my object store, just to make sure that everything works before I go ahead and do this at scale. And so you can see here, I'm going to do create external tables, post embeddings external with the location of just the forward slash, which is the base folder of the bucket. They receive the data source is external storage source, which is just the network location of my object storage in a file format is going to be Parquet. And on line 77, just to select top 10 from the post embeddings table, which is a table that includes the post ID, the actual embedding itself, and some date information about when that embedding was created and updated. Scoop that from that code, scoops those rows up, throws them into the external object storage. Now I come back and just ask for those rows. And there we can see the top 10 rows with the post ID, the embedding, and kind of the when the embedding was created. Those embeddings haven't been updated yet, so that value is still null. We'll come along later in our series here, and I can show how to maintain embeddings over time. As things change in our data, we'll have to generate new embeddings, and we'll see that be updated at column get populated.
We should have done an
So,
episode like that TV show 24 where people actually watch us create the embeddings for the entire Stack Overflow thingy
yeah, that'll
in
get
real
boring
time,
really
like
fast. Yeah,
over 24 hours.
yeah, yeah. All right, so let's talk about what's in the Stack Overflow database that I'm using. So go ahead and set our context there. And excuse me. And I'm going to use an aggregation query to just go ahead and count all the posts by year. And so we'll see in the data set at the bottom, our data set starts in 2008, goes all the way up to 2022. And
Oh,
so now what I
2008,
want to
that's perfect. There's got to be a lot of VB6 content in there.
there's totally some VB6 content in there. Actually, we should change this demo to look for that. Exactly. And that's kind of the point, right? Do I really want to have embeddings from 2008, 2009, 2010, and the gigabytes of storage associated with those on the hot block side of the house inside of my database? So when I come along and I back up the database or I create another index, like that, all that's going to be weight on the block side of the house. So I run a backup, I got to scoop up embeddings from 2008 and write them out and then restore those. And that could impact my recovery objectives and take up a lot of space on kind of the high value storage in my infrastructure. And so what I want to do here is just highlight how I could take these things and separate them out and reduce the amount of data that's on that hot block side of the house, but still have access with basically no code changes or close to no code changes to the entire set of data. So let's go ahead and start that process here. What I have on lines 113 all the way up through lines 145 is the code that basically loop through each year and create a separate folder inside of my external bucket for each year of data, and then use CTAS to generate the Parquet files associated with that. So it's got to run this code here. So in real time, I'm going to go ahead and loop through all of those and also generate the Parquet files and write them in the object.
Uh-huh.
On my infrastructure, this takes about a minute and a half to run. So, Ben, let's just fill up the next minute and a half with a bunch of annoying banter for our customers and viewers.
I don't even know where to start because I feel kind of limited by only having 1.5 minutes because that's usually, see, think of me as storage, and now everything needs to be bumped up into memory first so things get really fast so the bantering can really start. So I
Yeah.
don't even know how to respond at this point.
Well, actually, there's a cool technical sidebar we could go down right now. When you are using external storage, especially Parquet, when you interact with that external storage using this polybase integration, those accesses are non-buffered, so they won't hit the buffer pool. The things that are on the block side of the house still will hit the buffer pool as normal. So anytime I reach out and I talk to an external Parquet file, I'm going to read the entire Parquet file and pull that in a non-buffered way to my application or to my database engine
However, my storage may actually be caching. Either it's very fast storage as is, or it may actually be caching that file,
on the
right?
storage side of the house.
On the
Yeah,
storage side of the house.
but
Yes.
not in the
Yeah, yeah,
engine.
yeah. No,
Right? Yeah, yeah. I was being specific to the buffer pool there.
no, and I think that that is a very important distinction. So even with all the goodness that we've seen in terms of performance, and
Hmm.
I mean we've seen that last week, and yes, I give you that. My sales data may not have been as exciting, but we were reading and scanning and all that relatively fast through a good amount of data.
Hmm.
It will still be handled different than data that sits in a native SQL table.
Yeah, so let's check out what we did here. So you can see as I went through it, it scooped up all of those rows and stuck them in external storage. Let's pop over to my instance here, my server, to where I have the S3 browser. I go ahead and click refresh here. There we see the Parquet file that was the 10 rows that we stuck in there
Uh huh.
initially. I double click on Post Embeddings Archive, and there we can see a folder for each year of our archive data. So Ben's Very high value VB6 content will be in this 2008 folder, and there's the Parquet files associated with that. One thing that is important to call out here is I took about 13 gigs of data, parqueted it, that's the verb form of Parquet export, and wrote that into object storage. And it takes about 8.1 gigabytes on disk. So there's pretty good compression, even for this binary data that is the embedding that's occurring. So we're reducing that data set slightly as you write it to external storage.
I'm pretty sure parqueting is not the verb, but I may be wrong.
All right. Well, we can use that in a hashtag in a LinkedIn post when we describe this
I
video.
like that.
Cool.
What's the Italian verb for parqueting?
Uh, Paccheriamo. No. Paccheri. All right. So
I'm pretty sure
let's,
parqueri, that's some kind of pasta, but
yeah, definitely. There's some regionality there. All right. So let's create a real block table, right? So I'm going to create table, and I'm going to create a table to stick all of the newer data into. So 2022 forward. And so there we see create table. It's named post embeddings 2022 and later. The post ID is going to be a primary key cluster because it's a requirement for a disk and vector index. There's our embeddings with a dimensionality of 768. And then again, we have the created at, updated at, and it's going to be created on a file group, embeddings file group. Let's go ahead and create that table. Because now what I'm going to do is I'm going to go ahead and scoop up all the records out of the base table and stick them into this table. And so what I've done so far is I have all the older stuff, 2022 or 2021 and older on object, 2022 and later is in this table. And what we'll do next is drop the original post embeddings table and then just swap the names.
Uh-huh.
Cool. So that's finished. We'll swap the names. So now our got to run that code to actually drop the table and then swap the names, Ben. So what we have now is in the post embeddings table is just the 2022 and newer stuff, and all the older stuff is on object. But I want to be able to access all of the data. And so we're going to create a view here called post embeddings all. And so now I have post embeddings for the block side and post embeddings all, which encompasses a view that encompasses the post embeddings and all of the object data. So I can access that in one shot if I want to. So imagine at the application tier, I have a search box where I natural language process into. I type in my query.
Yep.
I hit enter. I hit the block side of the house, or maybe a checkbox there that says search all data. And then obviously from an application standpoint, I'll just come along and hit this view, and then I can go ahead and scan the data. So it's going to run this code to create that view. It's a very long view because it's encompassing all of the external tables year by year that we exported out to object storage. And so we'll come along now and run that aggregation query that shows us the post count like we did in the beginning to see the what and the where. And we'll find out in a second. We still have access to Ben's business critical VB6 content from 2008. Haha. But all that stuff from 2021 earlier object, 2022 newer block. And one important thing to call out here is the performance implications of this. That entire scan took 2.7 seconds. And a vast majority of those post embeddings, about I think it was like 8 to 10 gigs of it, were completely external, right? So we're getting some pretty fantastic throughput from an application standpoint. Also, interestingly, you see I have on line 235, I'm defining a max DOP of 16. Each one of those Parquet scans that's on external storage is parallel. So those are reading in concurrently into the system. So very interesting performance optimization there when you have to scale these kind of systems. Let's go ahead and check out what we're looking at from a storage standpoint. The original base table, before I started cleaning everything up and sticking the embeddings external, was about just shy of 13 gigs. Now we're just over 2 gigs, which is still on hot block. So maybe I want to reclaim that space and shrink the file that those things were into so I can reclaim that. So imagine this at a larger scale. This could become a significant reclamation of space. Here I'm going to reclaim about 10 gigs in my test environment here.
Which, to be quite honest, I mean, in the end, it's always a bit about the proportions. So percentage-wise, you're still reclaiming a lot, even though it's only 10 gigs. And again,
right,
if you're in a lab environment, that may also just be one of those cases where even 10 gigs is a lot because you're saving everything locally. So
exactly.
As much as people tell me not to run shrink, I think this is one of the use cases where it's perfectly fine.
Exactly. From a space reclamation standpoint, this is very common. And obviously, we would need to cultivate the indexes in the base table to make sure that things are stored in a way that makes the future Anthony happy, right? Basically, defragment those databases because external fragmentation matters in scenarios where you have things like read ahead scan, which are used frequently inside of Enterprise Edition. With that said, let's perform a KNN similarity search on our system. And we're going to go ahead and run this code here against the post embeddings all table to search for anything that's got or any posts that have issues with SQL Server
You mean
performance.
is uses?
Issues, yes, obviously highlighting the similarity of similarity search there by intentionally misspelling issues.
And that's what I do.
Uh,
Whenever I have a typo somewhere, rather than fixing the typo, I just add a comment that this was intentional.
Exactly that. But obviously, if I was writing a T-SQL query using just kind of traditional search, I would get no results. But here you can see in
Correct.
the output, I'm getting all the results in our data set associated with SQL Server performance issue. And in 17.5 seconds, I scanned the entire data set across both object and block. Again,
Yep.
pretty powerful to be able to have that level of performance and also this level of functionality, but having kind of the highest value data accessible in the hot block side of the house and the very highest value data, sarcasm, of the VB6 information from
I was going to
2008
say,
on
because I'm pretty
external
sure the
storage.
highest value data is what we've actually pushed to the S3. But
Precisely.
good, same page.
But some key points that I want to make going forward, right? Next, we could add a disk and index on the block side of the house, which would get us a much more efficient access to the data on that with an approximate nearest neighbor search. As we discussed previously, the embeddings now that are on external storage are accessible to other systems. So they don't have to do that work to generate those embeddings. Or as you pointed out, it could be a third party application. And next, I could do something like just build an automation that does this for me, scooping up that data and sticking it out maybe annually or quarterly or whatever business interval is important for that. So, any thoughts or comments, Ben, about what we did here today?
Well, first of all, I love that we found a special place for all the very golden VB6 content. I may have written some of it, who knows? No, but I think this shows also, again, how powerful embeddings are, but also how you can bring all the goodness of new/new-ish, because, I mean, as we've pointed out last week, the S3 access has been a thing since 2022. So
Right.
while the feature itself, it just got easier. And bringing those together, that again adds a lot of value, especially again also in circumstances where either you're really just archiving off old data, which is what we did here, but also in cases where like, yeah, I don't really want that sitting in my core database for honestly whichever reason. Either you just wanting to be slightly cautious about what actually ends up there, or because you can't do changes. I mean, sometimes your application may actually just be overriding your changes and all that. So
Right.
no, I think this is gold, not just the VB6 part.
Yeah, true, true.
Shall we play the music?
Let's play the music, Ben.